So this session is called Math Shifts, and we are going to talk about what Common Core looks like in the elementary math classroom. So I want to start off by talking about the 8 mathematical practices, and these are in your packet on page 9. In your packet, they're organized a little bit more graphically, conceptually, up here, sequential in order. I want to highlight a couple of them. The reason I chose to start with the 8 mathematical practices is because these are really one of the hallmarks of Common Core math. And the great thing about the practices is that they span K-12. So from kindergarten up to 12th grade, no matter what level of math your child is working on, these are the strategies that we're using to encourage your students to think like a mathematician, to really engage in that conceptual reasoning. So I'll talk about a couple of them. Number 1, making sense of problems and persevere in solving them. Perseverance has been really a great skill for students working with Common Core math problems. The problem you're going to see tonight is an example of Common Core math, and it's not that instant gratification that we're used to. I remember being in school and doing math problems, and I was able to do a lot of problems and do them quickly, and I kind of knew that I was getting them right. The problems you're going to see now have more levels, more complex steps, and students really have to persevere and stick with it as they work through. I'll skip to number 3, construct viable arguments and critique the reasoning of others. So we want students to be able to explain how they came to their answers. In the past, you'd have a classroom full of kids and somebody would raise their hand and say the answer is 7. And as the teacher, you would say yes, and you would move on, or no, and you would pick someone else. Now the question is, how did you get 7? The students need to be able to explain their steps, as well as listen to somebody else's explanation of steps. See if their reasoning is logical, if they use the same strategy or a different strategy. And another practice worth highlighting is number 6, attend to precision. We still expect our students to get the math correct and get it correct quickly. So we're asking them to persevere through difficult problems, explain their reasoning, engage in mathematical conversations, and be very precise in their calculations. So what you just saw, the mathematical practices, represent kind of the conceptual side, the habits of mind of Common Core math. Here we have what we call the Common Core math shifts. These are the changes on the instructional end. These are the things that look different in the classroom. So the first math shift is focus. Focus strongly where the standards focus. Historically in this country, math education has been what we call a mile wide and an inch deep. Have you heard that before? So we cover every topic every year. And then what happens over the summer? You go on vacation, you forget some. So you come back and review and you cover every topic every year. And in our drive to get through the text and cover every topic, we're only going about this deep. Now with Common Core, there are fewer standards, so it's not a mile wide anymore. And we're able to learn them at a deeper level. It's not an inch deep, it's a whole lot deeper. So over the summer, if we forget a little bit, we still have a good base. And that's where the next shift comes in, coherence. So we want to connect learning in and across grade levels. Instead of teach everything, review, teach everything again, we want to teach a little bit, teach it well, learn it well, apply it, and then build on that learning in the next year. And the third shift is rigor. And when we hear the word rigor, we think, oh, it's going to be more difficult. Yes, it's going to be more difficult. But not just across the board. This isn't just pick a difficult problem and give it to your kid and see what happens. It's focused rigor. The first area of rigor is conceptual understanding. So this is that big picture idea. If your children are learning fractions, it's not enough to know numerator and know denominator. You want them to conceptually understand what is a fraction. What is a part to a whole relationship? What does it mean if I ate 1/3 of the pizza and somebody else ate 1/2 of the pizza and then somebody back there ate the whole pizza? What's the difference? Procedural skill and fluency. Fluency is what we used to call math facts. Have you heard that before? Students need to know their math facts. So things like times tables. When you see the kinds of problems our students are doing with Common Core, they don't have time to count their times tables on their fingers. Have you seen this? It's the what's 6 times 8? I forget. Next thing you know, their socks are off, they're counting their toes. We don't have time to get caught up in the computation. So we want students who are fluent with their computation so that they can tackle the conceptual understanding and apply their knowledge in new settings. So application is the third area of rigor. With Common Core, all 3 areas of rigor are applied with equal intensity and equal importance.
Okay, if you wouldn't mind now turning to page 10 in your packet, you're going to have the opportunity to experience one of the problems as one of your students would. This is actually a 4th grade math problem. It's a release question from the Smarter Balance test. So the problem states, Miss McCrary wants to make a rabbit pen in a section of her lawn. Her plan for the rabbit pen includes the following. It will be in the shape of a rectangle. It will take 24 feet of fence material to make. Each side will be longer than 1 foot, and the length and width will measure whole feet. So the direction is, use the grid to draw 3 different rectangles that can each represent Miss McCrary's rabbit pen. Be sure to use all 24 feet of fence material for each pen. So you'll have a minute or 2 now to go ahead and try that out. Okay, due to time, we're going to go ahead and just point out a few things here. One of the things so example answer would be 10 feet by 2 feet. Another one would be 4 feet by 8 feet. Another example is 6 feet by 6 feet. And a key point here is that these are possible answers, and that's really one thing we're trying to teach the kids, that there's not always just one answer to a math problem. And in this case, we might ask them, maybe there's more than 3, so we can go deeper in our understanding. Another thing we wanted to point out here with the last example, 6 feet by 6 feet, this is actually a square. But the children would really need to have a good understanding of math, even though they're asking for a rectangle, that all squares are rectangles, though not necessarily all rectangles are squares. Another key point here is that this is part A of a problem, so which means there's part B. And when we talked about that perseverance, that the student really is going to have to persevere. Maybe they're not going to have as many problems, but they're going to go deeper and with their understanding of the problem. So in this case, the other thing in this case, we have length and width, but this child would also be asked to find area. So again, really, you're going to need to have a full understanding of that math problem. For part B, Miss McCrary wants her rabbit to have more than 60 square feet of ground area inside the pen. She finds that if she uses the side of her house as one of the sides of the rabbit pen, she can make the rabbit pen larger. So the student would be asked to draw another rectangular rabbit pen. Use all 24 feet of fencing for 3 sides of the pen. Use one side of the house for the other side of the pen, and make sure the ground area inside the pen is greater than 60 square feet. So here, it's really applying math. So we understand that if you're using the side of the house and you're using the same amount of fencing, you're going to have more area for that rabbit. So it's a real good example of using math to solve problems that are real life.
So in a teaching situation, we want to respect a student's method of solving the problem and then challenge him or her to solve it another way. So with the rabbit pen example, in the classroom, we might not say that you have to find 3 pens that work right away. We might say, find 1, see how many you can find. With the rectangle and the square, we might say, oh, I see you made 3 rectangles, great job. Is there another shape you can use that fits the requirements of the problem? When we're building a fence with the side of the house as one side, some students might find that really quickly, and we might ask them, great, now what's the optimal sized fence? How can you get the most area for the amount of fence you have? And challenge them to extend it that way as well. So how are things going to look a little bit different? Before Common Core, we had many problems all solved the same way. 1 through 20, we're going to do multi-digit multiplication to solve all these problems. And it would usually tell you what strategy to use at the top. Now, we're seeing more problems like the rabbit problem, where the problem is solved multiple ways or using multiple strategies, and the students have to identify the strategy they want to use. Before Common Core, we emphasize the correct answer. With Common Core, not only do we expect our students to get the correct answer, we expect them to be able to explain the why and explain the how.